An exponential function is a function that can be written in the following form, where y is equal to a constant a times another constant b raised to the x power. So the values that we plug into this function are actually going to be the exponents on b, and we call b the base because it's the base of an exponent. And the requirements on b will be that it has to be greater than 0, and it also can't be 1. A is called the coefficient multiplying our exponent. And the only rule here is that a can't be 0. We'll consider two types of exponential functions, exponential growth functions and exponential decay functions. Now they're both going to have the equation y is equal to a times b to the x. The difference is going to be the value of b. Exponential growth will occur when b is greater than 1. And exponential decay will occur when the value of b is between 0 and 1. For either exponential growth or decay, if we plug in the value x equals 0, we're always going to just get a, because b to the 0 power is equal to 1. So when we plug in a 0 for x, we're just going to get a times 1, which is a. So the point 0a is our y-intercept in both cases. What's going to change is the picture of our graph. The exponential growth graph is going to get larger exponentially as we move from left to right, and the exponential decay function will get smaller exponentially as we move from left to right. Now, in order to graph these specifically in a lot of types of software, we need a second point. So another thing that we can do is plug in x equals 1, and when we do that, we get y is equal to a times b to the first power, or just a times b. So the point 1, ab, is on both of these graphs. It's just in the first one it's going to be higher than the point 0a, and in the second one it will be below the point 0a. So here's the point 1, ab in this case. In this example, we're supposed to write an equation for an exponential function that begins at 19 and has a growth rate of 0.62%. So we know that since this is an exponential function, it will have the form y is equal to a times our base raised to the x power. Now a will be the initial value, or where they're saying the function begins. So we have a is equal to 19. To compute b, we need to compute the multiplier for the growth rate. So b is going to be our multiplier, which is a growth rate, and so we'll do 1 plus our percentage written as a decimal. Now we need to move the decimal place over to the left twice to get that, so it'll look like 0.0062 for our decimal. So b is going to be 1.0062. So our function will look like y is equal to our a value of 19 multiplied by 1.0062 raised to the x power. Let's check for understanding. Work this one out on your own first and then come back and double check your answer. Here we're supposed to write an equation for an exponential function that begins at 11 and has a decay rate of 0.65%. We know that our function is going to look like y is equal to a times b to the x. A is the initial value, and the prompt tells us that the function begins at 11, so a is equal to 11. And we know b is going to be the multiplier. This is a percent decrease, so we'll take 1 minus our percent written as a decimal. That will be 0.0065, which gives us 0.9935. So our equation will look like y is equal to a, which is 11, times b, which is 0.9935, raised to the x power.